chemical versus molecular formulas. If you have not quite mastered the stoichiometric ability to change from grams to moles, you might want to practice that a little bit, because we're going to use that all the time on this one. So go ahead, take out your notes, and let's get started. So the first thing we need to talk about is percent composition. Percent composition is just how much of one substance there is out of the whole, okay? So percent is part out of the whole, times 100. So percent composition for a compound would be percent of one element out of the total mass of the other compound. So, find the percent composition of girls in the class. Well, let's say that I have 17 girls and, I don't know, 12 boys. I think that's my ratio, but I could be wrong. So 17 girls plus 12 boys is equal to 29 total students, correct? So in order to find the percent composition of girls, I would take the number of girls, 17 girls, divided by 29 total students, and I would get 0.586. Then a percent, I always have to multiply it by 100. So I'm going to move the decimal place over by 2. 59% of my class is female, or are girls. Okay? So if I wanted to find out the percent composition of hydrogen in water by mass, I know water is H2O. I look at the periodic table. Oxygen has a mass of 16 grams per mole. Hydrogen has a mass of 1 gram per mole. In water, there are 2 hydrogens, so I'm going to multiply this by 2 to get 2. 16 plus 2 is 18 grams total. And since it wants the mass of hydrogen, I'm going to take hydrogen, which is the 2. 2 divided by the total 18 grams is equal to 0.11, which multiplied by 100 is 11%. So water is made up of 11% hydrogen. It's just a way of saying how much hydrogen is there versus how much oxygen is there. Alright? So if you would, I need you to practice this to see if you have it. Please do question 3 and question 4, sample problems. Pause the video and please do them. Alright, the first thing I like to do is I write out all of my information. So this is how much sodium I have, this is how much oxygen, hydrogen, and there's 4 grams total. So in order to find my percent sodium, I take 2.30 grams of sodium divided by the total 4 grams. In order to find oxygen, 1.60 grams of oxygen divided by 4 grams total. And I take 0.100 grams of hydrogen divided by 4 grams total. Okay, so 0.575, I move the decimal point over 2 and I get 57.5%. Over here I get 0.4. Looking at my numbers, I see I have 3 sig figs here. I have 3 sig figs here. So when I move the decimal point over, I need to make sure that I include the extra zeros. So it's not 40%, it's 40.0%. Hydrogen, move that sucker over, and I get 2.5. If I notice, there are 3 sig figs in this one, 3 sig figs in this one. So this means a 0 right there. And that's how you do percent composition. So in example number 4, instead of giving us the masses and asking us to go to the percents, now they're giving us the percents and asking us to go to the masses. So if I write out my equation, my percent is the mass of the individual over the total multiplied by 100. So I'm going to rearrange this so I solve divide by 100. So I'm going to take my percent and divide it by 100. And that equals the mass over the total. Then I'm going to multiply by the total on both sides. So that way I have my equation. Mass is equal to, or the mass of each element is equal to the total mass times the percent and divide by 100. Go ahead and try it again if you couldn't figure that part out. So for carbon, I took the total mass times the percentage divided by 100. But then for hydrogen and fluorine, I know that in order to change the percentage, all I have to do is move the decimal place over 2 spots. So instead of dividing by 100, I changed the percentage into a real number. That way I could just multiply them across with one step. Alright, so here are my answers. That's how many grams are in each. If I notice, I have 3 significant figures in my percentage, and I have 4 significant figures in my mass. So I need to make sure I have 3 significant figures in my answer. So for carbon, I have 0.203 grams. I have 0.0343 grams of hydrogen, and I have 1.33 grams of fluorine. Okay? So as you're looking at these, make sure you can go by mass or by percent abundance, and make sure that you can go either way. Okay? So now that we know percent by mass, percent composition, what we call it, we can determine the empirical formula. Okay? So first off, this is something you'll want to know. An empirical formula is the simplest whole number ratio of atoms in a molecule. Okay? So empirical formulas are always whole numbers. And C, go ahead and highlight this guy. That is the rhyme we use to find empirical formulas. So let's give it a shot. Alright, so this guy right here, our rhyme, this is what you guys want to have in your head. So the rhyme goes, percent to mass, mass to mole, divide by small, multiply till whole. Okay? That's our rhyme, and it works for every empirical formula. This is what it means. So a compound was analyzed and found to contain 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. What is the empirical formula? So empirical formula means smallest mole ratio. So the first thing in my little rhyme is percent to mass. Well, if you notice, we start out with mass. So in this case, I'm just going to skip this step because it doesn't apply. They don't give me percentages. My second step is mass to mole. In order to get a mole ratio, I have to have them in moles. So I put grams on bottom, moles on top. I'm going to look at the periodic table in order to find my grams to mole ratio. And when I look at the periodic table, I find out that calcium has a mass of 40 grams in 1 mole. Remember, on the periodic table, the mass is the number on bottom. Okay? So calcium has 40 down here. The units are grams per mole, so that's my ratio. Then oxygen, there are 16 grams in 1 mole of oxygen. And for hydrogen, there is 1 gram for every 1 mole. So hydrogen's easy, it's just the same thing. Mole. And then I do my calculations for the other two. Alright, so now I have my mole ratio. Shit. The next thing is I need to divide by the smallest. So now that I have my moles, I'm looking for the ratio between them. So I look for the smallest whole numbers, so I don't have to multiply till whole. It doesn't apply because these are all whole numbers. So in order to get my empirical formula, calcium needs a 1. So I'm going to have calcium. Oxygen needs 2. So O2. Hydrogen needs 2. So H2. Now if I look at this, it might look something like that. Calcium hydroxide. So the empirical formula is the lowest whole number ratio you can get. For an ionic compound, that means that it is the empirical formula that you would get based on charges. Okay? So if you notice that it is an ionic compound and not a covalent compound, you can always just kind of skip this step and balance using the charges. Okay? Now that you've had an example of how to do empirical formulas, go ahead and try number 6 by yourself. And actually try it. Alright, given the information, they give me the percentages of each atom, and they give me the total. So I have 2 ways to go here. I can either multiply the percentage times the total mass to get the individual mass of the carbon, or I can assume that I have a 100-gram sample and just change the percentages into grams. Either way will work. I personally find this one a little easier. So the first step of my rhyme, percent to mass. I can either multiply to get the actual mass or just pretend I have a 100-gram sample and change percentages to grams. Then I need to go from mass to moles. Now that I have the moles, I'm going to go moles divide by small in order to get the ratio. Now I have all whole numbers, so I don't need to multiply them by 2 or whatever to get rid of a decimal. So here is my ratio, all the way down here and all the way down here. Done. So now I just have to write the empirical formula, which is C19, H23, NO5. That is my empirical formula. How did you do? Now that you know how to get empirical formulas, you also have to know what the formula is in real life. Not just the ratio, but how many of each element are in that compound. That's what we call the molecular formula. It's the actual number of atoms in each compound. Okay? Again, they have to be whole number ratios, and it's pretty simple to get once you have the empirical formula. So since the empirical formula is the lowest whole number ratio, I know the molecular formula has to have this ratio in it. So what I do is I take the molecular weight, which is 180, then I divide it by the empirical weight, which is all of these guys added together. So the empirical weight is 30 grams per mole, because oxygen is 16, 2 hydrogens is 2, and carbon is 12. So I'm going to divide by 30, and I get, this gets me my multiple, so then I can do 6 times my empirical formula, and I get my molecular formula, C6H12O6. Now that you have an example, go ahead and try number 8. Push pause and try number 8. So the first thing I need to do for number 8 is find the empirical formula, using percent to mass, mass to mole, divide by small, multiply to whole. And the molecular formula is N2O4. Make sure you go over these notes and have an understanding, because we're going to finish the rest of this packet in class next time.